I was supposed to talk about closure, but I won't. The reason for that is that I submitted this closure talk a few months ago, and I couldn't learn enough closure on time, which is embarrassing, but it's true. It's embarrassing. I mean, I can joke about it, but it sucks, really. So I was left wondering, why is it so hard to learn a programming language? I mean, I should know better. I've been doing this for a long time. Still, it's consistently harder than I assume. Every time I learn a new language. And I believe that the reason has to do with the way my brain, and your brain for that, works. So this is what I'm going to talk about instead. Why it's so hard to learn a programming language. Let me talk about your brain, okay? Here it is. Congratulations, it's beautiful. And there are different models that try to explain how the brain works. Yesterday, Russ Olsen talked about the left brain, right brain. Today, I'm going to use a slightly different model. It's a model, so it's wrong by definition. It's not real, but it's, in this case, very useful. It actually won a Nobel Prize in this case. So, and I'm going to use a metaphor that is custom-made for us geeks. If your brain is a computer, then there are two main processes going on inside this computer. One is a low-level kernel process. And the other one is a high-level application process. And they couldn't be more different. First difference is that the application process is self-conscious. If you ask me about myself, the application process is what I call me. A cognitive scientist would call this my remembering self. The low-level kernel process happens without you even knowing about it. It's just working there all the time. Okay? And it's making weird associations because another important difference is that the high-level process is the logical one. It puts things in a line, it can analyze, it does numbers. Remember Russ's first talk from yesterday. It's good at numbers and statistics. While the low-level process is emotional. It doesn't really, it really sucks at numbers, frankly. But it goes on all the time. So it makes weird associations and it tries to find cause and effect. It tries hard, poor guy. It's not very good at that. So it goes like, you're looking at me, you say, hey, this guy has a beard, like my uncle. Oh, I like my uncle, I like this guy. Or, stuff like that, okay? Stuff like that. It's just connecting things in this weird way. Now, you might wonder, why are we built like that? I mean, we are a product of evolution. Why did evolution build a system that is so fallible, so silly, like our emotional kernel process? And of course, there is a reason, there is another trade-off. That is, the low-level kernel process is extremely cheap. And it's automatic, so it goes on all the time. And it's fast. So it's making these associations and taking decisions, actually, really, really fast. It gets it wrong, but it gets it quick. While the high-level application process requires a lot of effort. Now, don't get me wrong, the automatic process can do some amazing things. Imagine writing software to drive a car. You realize how hard it is. Still, you can drive a car automatically if you are an accomplished driver. It happens to you probably. Oh, I'm already home. On the other hand, if you do stuff with the effortful, expensive, slow, high-level application process, then you really consume energy. I'm not talking fluffy, new age energy. I'm real energy, sugars. Yeah, actually, it shows up in your body. Believe it or not, if you're writing complex code, your blood pressure rises majorly. Your pupils dilate. This is amazing. There are not many things in your life that can make your pupils dilate, apart from light variations, of course. So, one such thing is orgasm. Another thing is seeing something that shocks you, or thinking really hard. And then your pupils dilate. So we have these two systems, and of course they are not working separately, okay? The application process is conscious logical, but it requires effort and energy. The kernel process is subconscious, it always goes on, it's emotional, and they're swapping data all the time. Now, guess who's taking all the decisions? Well, both. But yeah, the low-level process has an unfair advantage. It's always on. It's always on. You cannot turn it off, even if you want it. And it's preparing data that the high-level process is going to use to reason about. So it's float data. Because there are things happening in here, mistakes, if you wish, repeatable mistakes. You don't get it wrong randomly. You get it wrong in the same way every time, mostly. And the high-level process is basing its very logical, very consequential reasoning on float data. So they are working together to take decisions, but as it happens, many of those decisions are wrong. And this is what a cognitive scientist would call a bias. Let's move on to programming languages. Why do I think that biases are important when you learn a programming language? When you're learning a language, you have to learn a bunch of stuff. You have to learn the syntax, of course. I'm not going to talk about that. That goes without saying. And we know it's not the hard part. Something surprisingly hard, for me at least, is learning the toolset that comes with the language. We take this for granted in a way. Okay, I will just learn this stuff. But actually, the tools are subtly and deeply, at the same time, different from one language to the other. Imagine that you are, I don't know, if you are a Java programmer or a C# programmer, this is probably your tool of choice, okay? An IDE. You start it in the morning, first thing. You wait for a while. Then you wait a little bit more. Eventually, it opens, and you barely ever you barely ever leave the borders of these tools for the entire day. Well, if you are a Ruby programmer, for example, you probably have a tool set that looks more like this. You have, a text editor and maybe a browser, and crucially, the command line. Now, I was always surprised and puzzled by the reason why the command line is not, doesn't spread in the Java world, for example. I mean, they are using the command line, but not quite as much as would benefit them. I remember I was working for a period with a bunch of C# programmers. These guys were really smart, AAA. And I was trying to convince them to use the command line, and it was just about, I just gave up. It was impossible. They were like, no, it's, the reasons didn't make any sense. Like, oh no, it's black. It's depressing. They were clicking their way through tasks for the entire day. These guys were smarter than I was. I didn't understand why. Experiment. Okay, you have these items. You have a candle, and a box of matches, and a box of pins, thumbtacks, okay? Your task is to attach the candle to the wall and light it. I want a lit candle attached to the wall, okay? Don't set the room on fire. Don't share the solution. Just keep it for yourself. Think about it. You have 20 seconds now. Uh-huh. Don't share. Time is over. Okay. You engaged your high-level application process. You were trying to follow logical reasoning, okay? Your blood pressure rised. Your pupils dilated. I'm assuming that nobody in the audience was having an orgasm. I mean, I hope you are having good fun. So, did anybody think of this solution? How many people? Just a handful of people. Okay. Now, just in case you think this was just an unlucky strike, when they tried this experiment, which is a very famous experiment in cognitive science, with a random sample of people, and they gave them real items they could experiment with, so they knew that, for example, the box was sturdy enough to hold the candle. And they gave them not 20 seconds, but 20 minutes of time. Only one person in 3 could come up with a solution. This is a famous experiment because it shows that there is something going on into your brain that scientists call functional fixedness. Functional fixedness means that when you use a tool, when you see an item, you associate the item with the function. And your low-level kernel process basically replaces the item with the function. So it says, box of pins, it's a box. It deletes the box. Okay? Because you know it's a box. It's not interesting. So your smart application process is going on, but using float data. Interestingly, if you show people the box and the pins separately, everybody, 100% of the people, come up with the right solution. How does that apply to the command line? As to a programmer who's used to work in a Windows environment, the command line is an application launcher. That's what it's for. You start applications with it, and then you close it. Unix programmer, that's a programming environment. You write code in the command line. Granted, it's code in a language that is primitive. It's called the shell, usually. Still, you use it for coding. And it's very hard to move out of that box. Another example. But first, let me talk about something else. Let me talk about bumblebees, because I just happen to like bumblebees, okay? This is a bumblebee. It's very beautiful. You like it? It's, I don't know whether it's anatomically correct, okay? But actually, last time I gave this presentation, a friend of mine in the audience complained about the nose. But now that Mr. fucking entomology is not in the room, I can tell you that I'm pretty proud of my bumblebee. And you probably recognize it as a bumblebee because it has this big body and small wings. In fact, there is this urban legend that says that if you do the math and you calculate the lift of the wings of a bumblebee, you will find out that a bumblebee cannot possibly fly. Its wings are too small. They don't generate enough lift. But bumblebees don't know math, so... And interestingly, there is something that's true about this urban legend. If you built a bumblebee this big, this large, 1-to-1 size, with exactly the same levers and weights proportional as a real bumblebee, then this bumblebee would not be able to fly. Its wings would be too small. So this is weird. Can you imagine the reason why? I couldn't, personally. What's different? I mean, size, but if you scale everything. Oh, you guys are wonderful. You don't scale air molecules. So it's weird that it does make a difference, but it does. Air molecules are the same size, so basically air feels more viscous at small sizes, and that's why the lift is much higher. I'm talking 1 order of magnitude higher, and the bumblebee can actually fly. This was an interesting piece of trivia. I will use it later, but never mind. Let's go back to programming, okay? Second challenge, you got to learn the design of language. Imagine that if you know some Java, imagine that you get called to evaluate the quality of a Java system. And you can peek at the code, browse the code for 10 minutes. What would you look for if you are a Java programmer? Is anybody a Java programmer in the entire room? Oh, all right. What would you look for, us? Yeah, good. The classes are probably supposed to be small. It's a hint. But if I see one big class containing a lot of logic, that's a hint that the system is probably not well factored. And also the interfaces, meaning the methods, the number of methods of these classes, and literally Java interfaces, is supposed to be small. I mean, if a class has dozens of methods, then chances are it's doing too much. It probably violates the single responsibility principle. Also, class methods are a hint that the system is not very object-oriented. They call them static methods in Java. You probably don't want to have that, okay? Now imagine that this same Java guy starts evaluating a Ruby library. Active record. You know about this, okay? So you look at active record, how does it work? You basically inherit from active record base, and then you win methods. Some class methods like find, some instance methods like save, a lot of them. So many of them, in fact, that at one point I was wondering, how many methods does active record base have? You see where I'm going? How many instance methods? I'm taking bets on this. Don't try it now. Like? Huh? It's actually 306. Last count. How many class methods? It's yeah, over 500. Imagine a Java programmer looking at this library. Okay, of course, it cannot possibly work. It's crazy. I mean, it's a library like this is basically, if you look at active record, it's one big-ass class and nothing else. A few exceptions, maybe. And it has all these methods. This is, of course, unmaintainable. It cannot be evolved. It will be severely bugged. And it flies. What's the air molecule here? Yeah. It took me personally a few months to understand what modules are useful for. You know, you can understand the syntax quick. But the idea that you can have so many modules, and these modules can be tested in isolation, can be developed in isolation, They are completely decoupled. And then you take all these modules, and at runtime, you build this big-ass huge class that is not there in the source code, so it doesn't hurt you. It only happens at runtime. I took a long time to get there. This happens in general every time I learn a new language. There are constructs that are just unique to that language, or at least new to me. Like, in this case, mixed sins. They were new to me. This is something that in cognitive science is, this is not even a bias, it's arguably a family of biases. They are called linguistic relativity. It's the idea that the language you speak will change the way you think, you look at the word, your model of the word. It's also known as the Sapir-Whorf hypothesis. They were referring to natural languages, of course, but it applies to programming languages as well. Okay? So you learn the design, you learn the tools. Now we're getting into the hard part. What do I mean by learning the culture of a language? I went around and looked for web frameworks in Java and in Ruby that pride themselves on being simple. I just left out all the Java frameworks that are clearly inspired by Ruby frameworks, like Play, for example. It's inspired by Rails. And this is what I found in the Java world. There is this thing called Seam. It's pretty popular. And it prides itself on being very productive, simple if you wish. It has a lot of modules. It comes batteries included, everything, including, I don't know, asynchronous calls, mail, everything you could possibly desire from a framework. And if you download and print out the Hello World example, it's 7 pages, a 7 pages PDF. And they are aware that this sounds bizarre because they say, okay, you might think that we're crazy. How is that simple, 7 pages for Hello World? But once you learn Hello World, you can do pretty much everything, anything. Everything works pretty much the same in this framework, okay? So, and anything that you want to do, you can do it with Seam, usually by just using the included modules. This is very much the Java culture. Let's call it the do-it-right culture. You won't leave any stone unturned. You won't leave any use case unaddressed. I remember that I was working at one point with the team. I was in the team that developed Hibernate, which is a very popular object-oriented mapper for Java. And there was one user who wrote on the issues page, he wrote, oh, the configuration is slow. I was like, how is it slow? It's blazingly fast. I didn't even notice that a configuration was going on my system. And then we started asking the user, and we were like, how many entities do you have in your system? Entities are basically the classes that map to tables in the database. And he was like, oh, a few tens of thousands. And we were like, no, not records. So we are talking entities. Yeah, a few tens of thousands. And at that point, I realized that these guys were dead meat. I mean, I said, let's leave them behind. We cannot help these guys. They are working on a database that is tens of thousands of tables of legacy shit. We cannot help these guys. But the project manager of Hibernate said, no, this is a legitimate use case. We're going to address this and make configuration faster. This is the Java approach. In Ruby, of course. Sinatra. So this is Hello World. Now, you might complain that something in Sinatra doesn't meet your very specific use case. You might even say, okay, this use case is shared by 10% of your users. And imagine what Konstantin is going to tell you. OK, you fork, and you write code to cover your use case. Or, if you wish, you switch to another framework. Rails might be your thing. This is the Ruby approach. Let's call it the keep it simple approach. That's the main value. So, this doesn't mean that Java people actually enjoy that crazy complexity. And it doesn't mean, of course, that in the Ruby world, we want to keep it so simple as to be useless. We still want to address the general use case. But imagine two guys from these two communities talking over a beer. Well, happens all the time. So, Java. So you think this is a framework? Yeah, it's pretty neat, but come on, it's a toy. You don't want to use this stuff in production, do you? And the Ruby guy, hello world, 7 pages, huh? Give me a break. Okay? And that's pretty much what happens all the time. This is a cognitive bias going on that is particularly ugly. It's called ethnocentrism. It basically says, you know, my values are the values. So when I'm talking to somebody from a different community, I'm going to measure them by how good they are at my values. You like to win easy, huh? I mean, those are your values. Of course, you are better at them. And this happens all the time. And when you are learning, you have to overcome this. Because your first reaction when you learn something different is, this cannot possibly work. It doesn't conform to my values. Actually, I would contend that the hardest part is not the learning, but it's the unlearning. So I have another section about overcoming your prejudice. Concretely, go to any forum where they have a flame war going on. And you will see stuff like this. Java is better than Ruby for enterprise development. This is the common wisdom in the Java community. It's not based on facts. What is happening here is, remember the two parts of your brain, okay? The application process thinks, okay, I'm analyzing the situation, and I know that Java is, matter of fact, better than Ruby for enterprise. Actually, the low-level kernel process has to deal with this question: which language is better for enterprise development? And this is a very tricky, very hard question. It requires energy. It would require your pupils to delay it big time. So instead, what your kernel process does is it sneakily replaced it with another question. And the question is, how many enterprises do I know that do Ruby compared to Java? Oh, not many. So, of course. But actually, you are answering another question. Another example, just to say that in the Ruby community, we are not better at this than the Java community. Python sucks because of the indentation. How is indentation important? Okay, apart from the really deep issues like doing DSLs in an indented language, in a language with significant white space, leave that alone. Most people just look at Python and say, you know, this sucks. Question: how good is this language? Wow, hard questions. Pupil delaying question. No, you want to spare that energy. So your kernel process is substituting the question with, how familiar does Python code look? Same with closure. All those parentheses. Of course, you don't even see the parentheses after a short while, but you look at it, it's very alien. Alien, not good. Alien, bad, not trustworthy. This is your kernel process, okay? not similar to what I'm used to, not similar to me, bad, bad, bad. This is something that's called attribute substitution, okay? You have a hard question based on a hard to calculate attribute, you just substitute it with something else. Trustworthiness, familiarity, for example. Quality, rarity, the opposite, okay? So, and it's heuristic. Okay, it doesn't look familiar. I cannot exactly put my finger on it, but it looks bad. So we are back to the original question. Why is it so hard to learn a new programming language? It's so hard because you are biased. You have plenty of this. Functional fixedness, linguistic relativity, ethnocentric bias, attribute substitution, and about 100 more currently proven or theorized in cognitive psychology. And you have to overcome this stuff all the time. Of course, you think, I'm a developer. I'm a logical thinking creature, okay? Sorry, that is not the case. You're biased. And what can you do about this? This begs the question, right? Now that we know that we are, in a way, flawed by nature, by design, what can we do about our biases? Here we get really lucky, because this is a simple question with a very simple answer. How can I avoid my cognitive biases? I can't. I can't do that. There is actually a field of study called cognitive bias mitigation. They do experiments, they try hard, they didn't come up with much, frankly. Okay? Of course, if you develop a skill, then your kernel process will use kind of better data. This is what you call my sixth sense, my intuition, my professional sense that the system is good or not good. But there is no shortcut to that. And by the way, you might have better data. You cannot overcome your biases. In a previous version of this presentation, I was suggesting that maybe being aware of your biases is going to help. Yesterday, Russ also suggested that if you know that you have stuff like confirmation bias, you will be better at dealing with it. Now, this is true to a point. It's true in hindsight. But in general, there is an uncanny ability of our minds to ignore this fact, even if you know about it. I actually have, how much time do I have left, Paul? A few minutes. Okay, let me make another, another experiment on you, with you. Let me make another experiment with you. Sorry. Okay. Oh my. I have to unskip a couple of slides. Sorry. Hello. Okay. I have a rule in mind. Okay? These three numbers conform to that rule. I challenge you to first imagine what the rule might be. You formulate a hypothesis. I will just tell you that this sequence conforms to the rule. So do many other sequences. Make a hypothesis? Okay. Now, in your mind, make an experiment. I'm sorry, we cannot really do this. We don't have the time. But think of an experiment. Think of another sequence that you think will help you find out whether the rule is the right rule. So first you think of a rule, then you think of another sequence, and you are supposed to ask me, Does this sequence conform to the rule? Then I answer in you, yes or no. Okay? Let's try it with just a couple of people.
A sequence to help you prove the rule?
Yep.
How about 2, 4, 5?
2, 4, 5. Yes, 2, 4, 5 does conform to the rule. Another one. 3, 6, 12 does conform to the rule. Another one.
3, 2, 1.
3, 2, 1 does not conform to the rule. Stop here. You thought of a rule. By the way, the rule is any sequence of growing numbers, okay? By the way, okay.
Yay, Paul.
How many people thought of a sequence that validated the rule? I think it's most of you, okay? This is just a human. Of course, especially if the rule is very generic, like in this case, it's much better to invalidate the rule, like Paul did. Okay? But, you know, confirmation bias. Russ actually talked about confirmation bias yesterday. It's the tendency of your mind to confirm what it already believes, rather than try to disprove it. You knew about this, but you forgot it. It's very easy to see biases in other people. This is actually a bias. It's called the bias blind spot. Okay? So you can't avoid it. Awareness won't help you. Here is another example. This is a primary example of a bias, of a cognitive bias, optical illusions. Are these two lines horizontal? These two horizontal lines parallel? Yes, you know it, right? You can hear your kernel process saying, no, they're not parallel, but you are smarter than that, right? Okay, let's make the kernel process happy. Okay, now it can see that they are parallel, okay? Oh, stupid kernel process. Now I'm gonna put back the lines, and of course now you know, they're not parallel anymore. You can't help it. It's in your neurons, okay? It's in your neurons. You're screwed, ladies and gentlemen. You will get it wrong no matter what. And you cannot stop the kernel process. I mean, if I say elephant now, you will see an elephant. You will think of an elephant. You can't help it. Now, if I tell you that in a few minutes I'm going to say crocodile, and you think, okay, this time around I will not think of a crocodile, you can't do that. It happens whether you want it or not. Okay? It happens in your automatic, stupid, approximate, fast, cheap kernel process. Crocodile. So you will get it wrong. What can you do about it? Well, as usual, you can't avoid it. You can probably embrace it. So now this sounds fluffy maybe, but if you are humble, if you assume that you can get it wrong, it won't help you overcome your biases, but at least it will help you deal with them in the right way. I know that I might be wrong. So I will validate sometimes, but validating every time is going to make my life miserable. I don't want to make my pupils delayed all the time at a very high energy cost, okay? But I will be able to assume that I will get it wrong. And I will give myself the time to learn, be patient. So don't do anything stupid like, say, submitting a talk to a conference about a language that you don't yet know, assuming that, of course, you will learn it. And this applies to other people as well. So ultimately, it's about being nice. You know, that Java guy who just doesn't get it, he might be right. You might be wrong. You are biased after all. Yes, I know, of course you're very logical, of course you're thinking straight, you did your homework, but matter of fact, most of your thinking is done by the stupid, fast, efficient part of your brain. So being humble and patient And nice ultimately makes you smarter. Huh? Who would have thought? It sounds like self-help. It's brain science, actually. So the first, the next time around, I guess I'm going to talk about closure next time around. Okay, thank you.